Yeah, so we will continue from where we stopped in the last class. I don't know, do you remember where we stopped? We are dealing with exceptions. So I'll just summarize what we did and then we'll continue. Okay, we said exceptions is a beautiful idea. Two things to remember. One, it is there in almost every new language now. Python has it, Java obviously has it, C++ has it to a lesser extent, and C#, all the other languages which are coming, obviously have the same try, catch kind of concept. What is a good thing about it? It enables you to segregate code, which is real code and exception catching code or error management code. Why is that a good thing? When you read somebody's program and you want to understand what that program does, one of the things that you would want to make out is what does the program actually do. You see any program, one of the basic criteria is, the thing I was talking about exception management is, you have a block. If you want to try and understand what that code does, very simple, just read the try block. That will tell you what the code does. And once you see the catch block, that anyway is only to handle errors. It is not part of the logic. Only if problems come, the catch block is encountered. Then we saw how Java's exception handling system works. Just to jog your memory, we have a try block, we have a catch block, and we also have a finally block. Now why do we have a finally block? Reason for that is, very often, at the beginning of the try block, you occupy some resources, you take some resources. Resources could mean database connections, opening of files, could mean anything. So that you do at the beginning of the try block. Now you need to release them. Now if you put the release statement at the end of the try block, that's fine. But what happens if there is an exception? So any of these catch blocks will be encountered. So you need to put the release of the resources in every catch block. And if you imagine that there is one try block and 20 catch blocks, you'll have to put up the release code in every of the 20 catch blocks, and you might forget, prone to error. So in order to do that, in order to facilitate an easier way of cleaning up code, they introduce the finally section. And what does the finally section do? It's a section which will always be encountered, you cannot escape it, and all the cleanup code goes into the finally section. We saw that. And we said there is only one exception where finally does not execute. Do some of you remember? Sorry? System.exit is the only way you can get out of the finally trap. Otherwise you have to exit only through the finally. We saw that. Then the other important thing we saw last Thursday was the concept of checked exception and unchecked exception. The unchecked exceptions are those which are derived from runtime exception class. All exceptions which are directly or indirectly coming from runtime exception, they are called unchecked exceptions, or more generically, runtime exceptions. What is the thing with runtime exceptions? It allows your code to compile, and if there is a runtime exception, it comes up at runtime. That's why the word runtime exception. So if there are any runtime exceptions expected in your code, you don't have to write necessarily try and catch block. Even if you don't write for those exceptions, the code will compile, and the consequences, if the exception comes, your code will bomb without a proper message. So that is what we talked about, unchecked exception. Then we said checked exception. What did we say about checked exception? They are all derived from exception class, but not derived from runtime exception class. So all those which come under exception class but not runtime exception class get classified as checked exception. For checked exception, what did we observe? That you have to compulsorily do one of two things. What is one? Try and catch those exceptions. Examples of these exceptions we saw were IO exceptions, file not found exception. There are plenty of them. In fact, there are more checked exceptions than there are unchecked exceptions. We saw there are plenty of those exceptions. Now we have those exceptions, and we also said the other way of handling checked exceptions was that we need not try catch it, we can report the exception. Anyone remembers the keyword that we use for reporting an exception? Throws is a verb form, adverb form. Throw is a verb form. They are two different. Throws is to catch, is to report an exception, and today we will see throw. And what do you mean by throw? Creating an exception. We have not seen that in the last class. We'll see it today, for especially user-defined exceptions and all that. So we talked about checked, unchecked. Then we saw how do you report an exception using throws. How do you catch exception using try catch block. There's one more concept which we talked about in the last class, which was generalized versus specialized exceptions. We said we should always catch specialized exceptions before we catch generalized exceptions. If you do the reverse, then you'll get a compilation error, and it won't compile because Java compiler will say the specialized exception handlers which you have written below are never entered because the generalized exception handler will catch. And the underlying concept behind exception handling is base class reference can point to derived class object. That was the concept. That's why base class exception is able to catch all the exceptions of the derived class family. That is a fundamental law of Java or any object-oriented language. So that is where we are as far as exception management is concerned. Now we have just a couple of more topics to discuss, and then I'll give you a MCQ. Let's see how you do, and we'll also have a bunch of exercise, but that MCQ is important because it all deals with how much you have understood of exceptions, which I'm sure pretty little. So now what we'll talk about is how do you deal with what is called as exception propagation. What is exception propagation? Okay, or bubbling of exception. Okay, so listen to this, try and see if you can understand, and then we'll go forward. So I'm going to illustrate it, then I'm going to write code on it, and hopefully you will understand. So what is exception propagation? So let me talk about exception propagation. So imagine a scenario in which I have a class with a method M1. Now M1 calls a method M2. Now M2 is another method. M2 calls M3. And M3 is another method which calls M4. And M4 is a method. During the course of the method, during the execution of the method, there is an exception. Okay. Let's say an arithmetic exception. Okay. Now, the arithmetic exception, if it is not caught in M4, if it is not tackled in M4, then it propagates to M3, and any statements you have written here also won't be executed. These statements will not be executed because M3 called M4, and M4 had an unhandled exception, whatever exception it may be, and because M4 did not handle an exception, M4 came out with fire. So can you see fire burning? This is fire. So M4 came out with fire burning because there was no exception handler here. Because M4 terminated without an exception handler and there was a pending exception, these lines will not be executed. These three lines or whatever lines will not be executed and they will be skipped. So now the exception again will propagate to M2, which called M3. Again these lines will not run because M3 did not catch this exception. M3 had an option to catch this exception by putting a try here, but M3 did not catch it, and the exception propagated to the caller of M3, which is M2. Again, this method terminated with a pending exception. Again, it did not handle the exception. Neither, let's say, M2 handled the exception. So again, these statements did not execute. Again, the exception propagated to M1, which had invoked M2. Now it depends on M1 whether it wants to catch the exception or not. Otherwise, it will propagate, this will be skipped, and it will propagate to main. And let's pretend main catches this exception, that try catch. So in main, which calls M1, the exception is caught by writing a catch block and a try block. So the exception is caught here. Now this is called the bubbling of the exception from M4 to M3, M3 to M2, M2 to M1, from M1 to main. The exception bubbled up all the way up. And maybe main also, if it doesn't catch, then the program will bomb out. But if main catches it, then it will be handled there. Now, this is the concept of exception propagation, nothing else. What is it called? It's called bubbling of exception or propagation of exception. Now, I think it's easy to understand why it is called bubbling. Bubbling means like an oxygen bubble in a glass of water or in a jar of water. That bubble will go up, no? Like that. So it propagates up the call stack. So now, is it a good thing or a bad thing? Well, it's neither a good thing nor a bad thing. What is it? Now it gives you, many programmers are used to write code in either of these two styles. There are pros and cons of both styles. The bad effect you can see of not handling exception locally, that is in M4, is that it is disrupting the whole call stack. That is the bad aspect. But some people say that's really not a bad thing, because what we want to do is, we don't want to handle exceptions locally, that is in the same method. We want them to all propagate to main, and in main we will write only one global exception handler for that kind of exception and handle them all in main only. We will not handle them in the individual methods. Even if they are coming from whatever method they are coming, let all the exceptions flow into main, and in main I will handle them at one go. What is the reason for saying that? They say otherwise I have to write an exception handler everywhere. I'll have to write so many exception handlers in each of those methods. I don't want to write that. I want all the exceptions wherever they come, let them all come to the main. At main, I will handle all the exceptions in one shot. So I will be able to give uniform treatment to all the exceptions. So some companies, this is a company level policy generally, they say when you allow exceptions to come, don't catch the exceptions, let them go. Let them come up to the main, and in that main let's handle them. It's a way. Or as I said the other way, you handle the exceptions where they are coming. What happens, I'll tell you normally. Exceptions which are very specific to that particular method, they should be handled locally. But general exceptions like arithmetic exception, file not found exception, or many other exceptions, they can be going all the way up to main, allow them to bubble up to main, handle them in main, don't handle them locally. So that is up to you to decide. Normal guideline given to developers is, whatever is specific, particular kind of exception if it is there, like let's say you are playing a game and there is some trouble, you are developing a, let's say C++ or Java with a game, and let's say there is some trouble with a particular function call which is used only in that particular logic. So handle that exception right there, because it has no general effect. But if there is an exception like your GPU is not working or your GPU is not there, then most of your code is not going to work. So allow that exception to propagate so that you can handle at a main level, at a higher level. So both these things are allowed. There is nothing to say this is good or this is bad. Both styles are as predominant as any other. Now what we are going to do is, we are going to write code. Now I am going to call these methods from main. So I am going to make all these methods static. You can make them static or instance, doesn't matter. but because I am going to demonstrate to you how it gets called through main, I am going to create a main with 5 methods or 4 methods, and we are going to do this propagation and understand how the propagation works. So I'll create this 4 methods in main. Look at the way I'll create them. I'll start with M1. Okay, so the exercise that we have opened is, I don't know. Okay, day 13 Java Lab 1, that is what I see. Day 13 Java Lab 1. So we are creating a method M1. It is going to call M2, but just to give us an indication what is happening, we are going to have one line before and one line afterwards. So in M1, I am going to say print ln before calling M2. Okay, we will say before calling M2, and then we will say after calling M2. Okay, so we are done with M1. In a similar way, we would like to write M2, M3 and M4 before calling M3. Just trying to mimic these methods, you will have to make them static, otherwise they will not be invoked through main. So we will declare them as static. You know why we are doing that, right? Otherwise we can't call them in main. Main can only call, main is static, no? So static can call only static. It can't call anything else. So I have M2, I have M3, and well, I don't need so many, but it's okay. And I'll have M4, and now I'll have M4, which will actually throw an exception. So in M4, write that int a equal to 10, b equal to 0, something. Okay, int a equal to 100 by 0. Now you have to write something before so that we know, and it has to be called M4, no? Yeah. Print ln before division then we will write after division. And we will call this method M4. Okay. So this is our code. I'll just go through the code again. It's just setting up a propagation stack. That's all. Okay. So I'll just go through it again. You have a class test. M1. M1 calls M2. M2 calls M3. We put one line before and after so that we understand what's happening. And then we have M3, and then we have M4. In M4 we are doing something strange. We are doing a division by 0, and we are having before division and after division. Now we are going to call M1, and we are going to allow the exception to propagate to main and catch it in main. This is just to demonstrate that the exception is started in M4, that the fire has been lit in M4, fire started burning in M4, and it came all the way up without completing either M3 or M2 or M1. It erupted and came all the way up to main, and in main it was tackled. So that is what happened. So in main I will call M1. So we will put a try catch block around this. We will say try calling M1, and we will catch it. And okay. Catch arithmetic exception. We can catch either arithmetic exception or runtime exception or exception. But best thing to do is to catch the actual exception. arithmetic exception AE and print AE dot get message. That is a standard method available on any exception object. Okay. I am going to summarize the code again. In main, I am calling M1 and M1 calls M2, M3, all are static methods. That's why that invocation is allowed, otherwise I would get compilation errors right there. And then I am having these methods and I am having the main. In main I am catching an exception. So now we are going to play with this code a bit. So get this code in action, because I have not put finally yet anywhere, and we are going to put it, but before that I am writing a basic code and then we will experiment with this code to understand the dynamics of the behavior. Okay. Okay. So yeah. So let's see what happens when we execute. So what do you think is going to be the output? Okay. If you want, I'll add one more line in main before calling M1. You can add before M1 and after M1 I will say after M1. And then after having handled the exception in main, I will say end of main. After the catch block, I will say end of main. Okay. Now you guys have to look at it first without running it and tell me what output am I going to get. So let's give it a shot. So line 24 will run first. Yes. So I will get before running M1 or before M1. That will be my first line. Why will I get? Because I am running main. Before running M1, I am getting that line. So I get before M1. So now M1 gets executed. So let's see what happens in M1. Okay, let's go to M1. So M1 is going to call M2, but before that it's going to say before calling M2. So I have two lines now, before M1 and before calling M2. Then M2 is going to be called. So M2's body enters, and in M2's body we are going to say before calling M3. So three lines, before M1, M2, M3, all before. Then M3 is going to call M4. So I entered M3. So now I have one more line before calling M4. So four befores. Now M4 gets called. Then in M4 I am going to have before division. And am I going to see after division? No, yes. So five outputs before M1, M2, M3, M4 and before division. Now division happens. What happens during the division? An exception object is raised. So exception object is raised means now there is a burning exception. The M4 is on fire, right? Because M4 is on fire, that after division, will it be executed? No, it won't be executed. So the exception will propagate to M3. Why M3? Because M4 was called from M3. So it gets propagated up the calling stack. Calling stack means the invocation order. So it now will propagate to M4. From M4 it will propagate to M3. So in M3 there is a line after calling M4. So because M4 erupted with a pending exception, unhandled exception, the next line will not be encountered. That is, line 15 will not be printed. So exception again will propagate from M3 to M2. Again M3 is coming out with an unhandled exception. So M3 also, the next line after M3 and M2 will not be executed, because we know that whenever a method returns with an unhandled exception, the next line will not be executed. That block will be aborted. So because of that abortion, after calling M3 will not be executed. then it will propagate to M1, and in M1 after calling M2 will not happen, and it will propagate now to main, and so M1 will come out with a pending exception. So after M1 will also not be executed because at that moment there is a pending exception, but fortunately in that try block there is a catch and it will be caught. So end of main will be AE.get message will be printed because the exception is caught, and also the end of main, because at that point there is no pending exception. Whatever exception which got propagated all the way up to main has been caught in main, and after that the end of main is there. So there is no exception at that point. So how many lines in the output? Don't know how to count. How many lines in the output? I just went through with you in the code. How many lines are we going to see in the output? All the before lines, 5 before lines, 1 exception handler, caught exception, and 1 after main, or what is it? End of main, right? End of main. So we are going to see 7 lines in the output, okay? And you are going to understand why we are seeing 7 lines in the output. So let's run it and check what we see and confirm what we are seeing. Okay, let's look at it. So as we said, there are 7 lines. Before M1, before calling M2, before calling M3, before calling M4, that is 4, before division is 5, then this is when the exception was caught, I got divide by 0, this is the AE.get message, and then we got another line, end of main, which is the end of main. Right? So this is the exception propagation. This is the exception propagation. This is how it propagates all the way up to the caller if you don't catch it in between. Now, we are not done yet. Now, let's say I told you, you can put a try block without a catch block. You can have a try block with catch and with finally. That is a normal usage. You can have just try and catch. You can also have just try and finally, allowed. Now what we are going to do is, in all our methods, we are going to put a try, but we are not going to put a catch. We are going to put a finally, just to observe how finally behaves in exception propagation. How the behavior of finally is with respect to exception propagation. So let's understand. Now coming down, okay. What we are going to do is, just like we put a try catch block in main, we are going to put a try finally in every method. So we will start with M1. The whole 3 lines you put in try. We'll shift all the 3 lines into try. Okay. Here we go. And then we'll say finally. Remember, we are not having a catch block intentionally. It's correct not to have. I mean, it's not mandatory to have. Generally, you always will have try catch finally, but it is allowed to have just try and finally. So println, you will say finally of M1. Okay, we'll say finally of M1. Yeah. We'll pick up the same thing and put it in M2 also. Okay, we are replacing that code and we'll alter it accordingly. So we'll call it M3, 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 and we'll say finally of M2. Okay. And same thing we'll do with M3. We're just replacing the code with a try block. M4, M3, M4, sorry. Yeah, finally of M3. Good. Now again here also. Try finally. We'll say finally of M4. Okay, we are done. Okay. Now Now can you tell me how many lines will I see in the output? Let's just discuss that and understand and see whether the output measures up to what we think is the output. Okay, let's start with main again. So main, we will say before M1, then M1 will be called, and let's go to M1, and in M1 we'll say before calling M2. Now yes, before calling M2, so we have all the before methods getting called. We can run through them. Now we go to M2, before calling M3, 3 output, M3 before calling M4, 4 output, M4 before division, 5 output. Now exception comes on line 35. Once exception comes, it erupts from the try block, it aborts the try block because there is no catch block and it's an unhandled exception. Finally is executed. So once we have finally, we'll have finally of M4. So we have finally of M4. So how many output? 5. 5 so far. Before M1, before M2, before M3, before M4 and before division in M4. So 5 outputs. Then finally of M4, because that is where the exception came. Finally of M4, and then it erupts and goes to M3. M3, we are not able to handle the exception, but the finally cannot be escaped. So finally of M3, then finally of M2, finally of M1, and then the exception gets handled. So I have so far 9 outputs, then exception gets handled. So I have get message, divide by 0, then I have end of main, and in the main I have no finally. So how many did I get? 5 plus 4, 9 plus 2, 11. So theoretically speaking, there has to be 11 outputs on my screen. You know why 11? We just worked it out, and finally so what we are trying to show here is when the exception is bubbling up in the lower methods, the finally will still be executed even if the exception is not caught. So the propagation up of the exception does not inhibit finally from getting called. Finally does get called as it propagates up also. So finally has that effect, and that is a good thing. That is what it should happen. Okay, so let's run it and check. Okay, now let's see the output. So as expected, we have before M1, before calling M2, before calling M3, M4, that's the entry before division, and then there is the recoil. Recoil means the coming back, the retreat. That is the reverse way. Finally of M4, finally of M3, finally of M2, finally of M1, divide by 0, and exception gets caught by divide by 0, and because it is caught, end of main. So this is the propagation order of finally. Okay, now we have done this. Okay, have you understood? This is when I don't handle exception locally in M4 where it occurred. I am allowing the exception to propagate all the way up. Okay, it's coming all the way up to main and getting tackled in main. If it doesn't get tackled in main also, what will happen? Main will also come out, right? So this is one journey. Now you should be familiar with a related journey where I actually handle the exception in M4 locally. That is, exception is coming in M4, I will handle it locally in M4. Then how my output will change, how the propagation stack looks when I have handled the exception locally. What we are showing here, first time what did we see? Exception came in M4, no finally, no nothing. It propagated all the way up and it came there and it was handled. So we saw what output we got. Second case which we just saw, we wrote finally in every method, and we saw that though the exception when it is recoiling back up to main, finally is being executed. Finally is not being skipped. Finally does get executed. Okay, we saw that. And now we are going to see one more thing, which is how, if I handle the exception locally, what output will I see rather than globally. Globally means handling it in main, allowing it to reach main. Now I will not allow it to reach main, I will handle it there itself, where the exception comes. So there itself I will handle it. So let's see what output I get in that case if I handle it locally. So we'll go to M4, and as he is preparing the try block in M4. So we are going to handle that exception locally itself. So we'll say arithmetic exception AE, and we are going to say caught the exception in M4. We are going to give a nice println to say what happened. Caught exception in M4. Okay. Yeah. And we can also print the associated message with the exception if you want, plus AE dot get message. Okay. Now let's theoretically first understand what we expect to see, and then let's experiment it and check whether is that what we really see. Okay. So let's go through. So what will happen? All the before methods will call. So we'll have before M1, before M2, before M3, before M4, before division. All of this will be called. There is no surprise with that. Now so there are 5 outputs already on my screen, all the befores. Now there will be an exception on line 35 as usual, and line 36 will obviously not be executed. Why? Because there is a pending exception now. Now it has to enter the catch block. Now in this catch block the exception is caught, so I will get a message caught exception in M4. So now I have my 6th line of my output, 5 plus 1, 6th line of my output. Then because I have now caught the exception, or otherwise also finally cannot be escaped, so I will get finally of M4. So I have 7 lines of output now, finally of M4. Then it will go back, like what happens, M4 is done successfully. Now at the end of M4, is there a pending exception? Yes, no? No. At the end of M4, now there is no pending exception. Exception came in M4 and it was tackled in M4. So the whatever fire, as I was saying, which came in M4, that fire was doused in M4 itself. Now there is no pending exception coming out of M4. So when the control comes back to M3, so we'll go to M3, M4 returns but without any pending exception. There is no fire now. That fire was doused in M4 itself. M4 there was an exception, but it was tackled in M4 itself. Because it is tackled in M4 already, now when I come to M3, I have M4 tackled exception, so no pending exception. So there is no reason to abort M3 now, that code now. So line 26 will be executed after calling M4. That will be executed because no pending exception from M4. So now I don't know, I lost count. So maybe 7, maybe 8, okay, 8 output. Then from M3 the control will flow back to M2. Finally of M3, so 9. Again I may not have. Okay, then it will go to M2 because M3 is coming out without any exception as usual, as in this case. I have after calling M3, finally of M2, all of that. So where are we? 11. Anybody counting? 11. Okay, we'll go with 11. We'll go back to M1. Control will come to M1. Again 2 more lines from M1. So 13. Okay, and then it will go to main. So once we are in main, again no pending exception. So 14. And now there is no pending exception, so catch block will not be entered because it was handled there only. So 14 and 15 I think, end of main. I think I got the count right or wrong, I don't know. But there are 15 lines which are expected from our output because of the handling of exception. because all the afters will be executed because the exception was handled in M4. There is no propagation of exception. Exception is not any longer alive. It was killed in M4 itself. So now watch what output we see, and here we go. So this is the output. Okay. So how many lines? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We got it right. So before M1, before calling M2, before calling M3, before calling M4, before division, then division happened in M4, exception came, exception was caught in M4, then because the exception was caught or otherwise, finally, and after calling M4, executed. This was not executing earlier because M4 was coming out with an exception. Now M4 is not coming out with an exception, and therefore it is coming out normally. So whatever was there in M3 after M4 invocation, that will be executed. So we have after calling M4 and after calling M3, finally of M3 of course, then after calling M3, finally of M2, after calling M2, finally of M1, after M1, end of main. All of these are come because we handled the exception locally and there was no propagation of that exception. Anybody understood these three scenarios? We played with three scenarios. A, there was exception propagation, but no handling of exception, only in main we handled it. Second, we wrote a try-catch block in all the methods, but we didn't write a try-catch, we wrote try finally. We saw finally is getting called as the exception is propagating back. Then we saw this last case where the exception was handled in M4 itself, locally, that is in M4 itself, was not allowed to propagate up, and all the after methods got called. All the after printlns got called because there was no pending exception whatsoever. This is what executed, this is what ran. This is what is called the magic of exception propagation. But we are not done yet on exception propagation. Still, there is some more nitty-gritty involved and you need to understand it. Okay? I hope you are not tired already. Okay? Yeah. So now there is one more thing. Now we have watched exception propagation with what kind of exception did we experiment with? Was it unchecked or checked? Which exception were we creating? Arithmetic exception. What kind of exception is arithmetic exception? Unchecked, or also called runtime exception, correct? Now, what we are going to do is, we are going to take away that arithmetic exception in M4 and replace it with a checked exception and see whether I can compile the code. You will see, this is where a lot of Java programmers give up programming in Java or don't write exception handling only because they don't know. Because this is where you start understanding the clear difference between what is checking an exception and unchecking an exception. So far, M1 called M2, M2 called M3, M3 called M4. We just had to declare that exception, that's it. Now, what we are going to do is, we are going to go to M4 and we are going to have a situation where in the code, a checked exception. Now you know how to create a checked exception, correct? We saw that the other day. What is the easiest way to create a checked exception? Many ways. One of the ways you remember, let's see if anyone remembers. What is a checked exception that we use? You are really admirable. In the last class. Sorry? Class cast exception was not a checked exception, no. File? Yeah, file not found is an example of a checked exception. Anything to do with IO is a checked exception. There are many checked exceptions. As I said, there are many more checked exceptions than unchecked exceptions. So one exception we are going to use is file, do something with a file and therefore trigger that exception. Okay, so he's already put in that code. Okay. So, oh no, we are lifting that code from an earlier exercise. Okay. So, I'll put in that code. Yeah, we have changed M4. I'll just walk you through what changes we have done to M4. Why did we change M4? Because now I want a checked exception to come out of M4 rather than an unchecked exception. So far, we are having only divide by 0, which is a runtime exception. Now I want a checked exception and I want to analyze the behavior. Now, you analyze with me. So, I think the changes he has done are right there for us to see. We are dealing with file, not for any particular reason. So, we have file object created. Then if you remember, we are creating a buffered reader from the file object by first creating a file reader and buffered reader. Now I remember telling you, file reader can only read characters at a time, buffered reader can read lines at a time. So if you want to read data in lines, you must use buffered reader, you can't do it with file reader. So anyway, that is a conversion. Then we are reading lines, we are checking whether the line is null. If not, we are printing it out and reading the next line and we are closing the file. So some output will come. Okay, now if you notice, the exception which is expected is file not found, which is a derived exception of IO exception. The other exception expected is also IO exception, which is also a checked exception. All exceptions in this code are checked exceptions. Now you observe what will happen. The beauty of checked exception. Now my code is in M4. M4 is called by M3. M3 is called by M2. M2 is called by M1. M1 is called by main. This is our propagation stack, just to build a experimental stack, right? So now my first question will be, because now I have introduced a checked exception, now first let's say, will M4 compile? As it stands, will M4 compile? No, yes. What do you think? At this stage, I have a exception handler for IO exception. Okay. So will M4 compile? Yes, no. No. Yes. Remember, with checked exception, what is the thing? Either you have to catch them or report them. I have caught it in M4. So I have fulfilled the condition. So it should compile. Correct? With checked exceptions, either I have to catch them or I have to report them. There is no other option. Otherwise your code won't compile. If it doesn't see either reporting or catching. So I have got it, as you can see in line 48. I have made provision to catch it. So I have fulfilled that condition. So now let's see what happens, what output I get. Okay. So let's run it and check. Okay. So, oh sorry, that's some other error. Import spelling. Okay. Yeah, as expected, let's see the output. Okay. So I have befores, all before M1, M2, M3, M4, M5. Caught exception in M4, no such file, because today we didn't create any file. It was caught in M4 itself, finally of M4, after calling M4, finally of M3, all the finalies got executed and end of main. Very similar to catching of arithmetic exception. Okay. Only thing is the name of the exception that we caught there was division by 0. Here it is file not found, because apparently there is no file called file1.txt. I got that exception. Okay. Okay. Now let's not. I am going to remove or comment out. Let's go down. I am going to comment out in M4. I am going to comment out the line 48 to 50. 50. I am going to comment out. Okay. Will M4 compile? No? No, yes. It won't compile. Now, what I want to do is, okay, please now think with me. I don't want to catch this exception. What exception? File not found exception. I don't want to catch it in M4 where it occurs. Just like first time I allowed the arithmetic exception to propagate to main and caught it in main, I want to do the same thing with M4. Sorry, with M4 with the file not found exception. I want to do the same thing. So what I am going to do is, I am going to allow the exception to come in M4. I am not going to catch it there. I am going to catch it in main. So let's put this catch block in main, because I want to allow it to propagate. I don't want to catch it, allow anyone to catch it before. So now do it carefully. No, let that be there, doesn't matter. So add one more catch block which you copy from there. Now, so catch IO exception. Now we will say caught exception in main. That's the only line we will change. Okay. Now you have to understand something very important. Okay. I will first describe the scenario. There is a call stack, main calling M1, M1 calling M2, M2 calling M3, M3 calling M4. M4 is going to have an exception. What kind of exception? A checked exception. Is it being handled in M4? No. Why? What do we want to do? We want the exception to propagate all the way up to main, and we want to tackle it in main. We want to catch it in main. So we should allow it to propagate. Earlier, with arithmetic exception, we could do it very easily by saying catch it in main, allow it to propagate. And when it was propagating up, all the after statements did not run. Why did it not run? Because there was a pending exception. All the after statements did not run. I just demonstrated that. So the afters were not running. Only the befores were running. Now you will realize that this code will not compile. First of all, M4 won't compile. Okay? If you go to M4 and watch and see, if you look at M4, why will M4 not compile? Remember with checked exception, what is the rule? Either I have to catch it or I have to report it. Now I am doing neither. I am not doing anything in M4. I am not catching the checked exception, which is file not found, which can either be caught as IO exception or as file not found exception. I am not catching it. I am also not reporting it. Correct? So it won't compile. Correct? M4 won't compile. First let's ascertain that. Let's compile it and check whether, let's try to run it and check whether we'll get the thing. Now you'll get a bunch of errors which are good. So yeah. So as you can see, there are so many lines in which so we have to remove that catch IO. No, that is coming in line 60. Okay. No, leave line 60. That is the main. Now you notice that as expected, being a checked exception, the compiler is clipping on line 39, 40, 43, various places, saying, I don't see you even recognizing that there may be a file not found or IO exception. If you catch IO exception, it's on, because file not found is derived from IO exception. So I don't see any exception handler in your code. I don't see you handling the exception or reporting the exception. Okay. Now you will see something important. Now let's say I am a smarter Java guy. So I went to M4, and in order to get rid of that error, 39, 40, 43 and 45, I went to M4 and I said, I said throws exception. Throws IO exception, I did that. Now, the compiler will feel happy about M4. Why? Because at least M4 is recognizing, is telling me, yes, I may report an exception. I am not handling it, but I am reporting it. Now do you think code will compile? No, yes. M4 is happy now. Will it compile now? You see what? Now observe. Okay. So those errors will go, but now you will notice error will come in M3 who is calling M4. Now please at this point try and understand what is happening. M3 is calling M4. M4 is reporting what kind of exception? A checked exception. Please remember, M4 is reporting a checked exception. Are you getting me? So M4 has reported a checked exception. Now M3, which is calling M4, because the exception is not caught by M4, it is just reported by M4, the compiler says, Mr. M3, you are calling M4, who is a good for nothing, is not catching the exception which is raising, which is a checked exception. Instead, M4 is just reporting that exception. It is not handling that exception. And it's a checked exception. So I will not allow you to compile. Why? Because you are calling M4, which is going to come out with a potentially checked exception. And now, because you are the invoker of M4, you also have to be aware that your M4 is potentially throwing a checked exception. So either you catch it or you also report it. Are you getting me? So now you understand what you have to do all the way up to the call stack. Each guy in the call stack, if he doesn't want to catch that exception, check the exception, each of these call methods will have to report that exception or they have to catch that exception. Now I'll say to M3, which is calling M4, I go to M3 and I am now making M3 report an exception. Just see that. So now compiler will feel happy about M4 because it's reporting an exception. M3 because it's reporting an exception. Now it will go and catch M2 and say, Mr. M2, you are calling M3. M3 is raising a checked exception. It is reporting an exception. What are you doing about it? You catch it or you report it. Are we clear? So now you will get the trouble with M2 who is calling M3. Watch it. Okay, you got an error. Can we see that error? Okay, go there. Now, so now you will get an error in M2 where M3 is getting invoked. See that invocation M3. So it is on that line that it is getting an error. Line 16 if you notice. That is an exception because M2 is calling M3. M3 is reporting a checked exception. Now what M2 has to do? M2 also has to report the checked exception all the way up. This is a problem with checked exception. So M2 throws IO exception again. So I am calling M2. Are you clear? M2 is also reporting an exception. Now M2 is happy, but the compiler is happy with M2. He is reporting an exception. Now this story continues. So I have to report it in M1 also because it's a checked exception. And main, in main as you notice, going to main, in main I am now catching an exception. Now that error will disappear on line 60 because now it sees a clear propagation path up to M1 which is reporting an exception. Main will catch it. Okay. So now main doesn't report an exception because main is catching it. Now that code will run. The code runs and it produces some output. Obviously since there is an exception, all the exception is propagating all the way to main. All the after statements are not executed, only finally is executed. Okay. So this was the fourth scenario. What was the difference here? We are dealing with checked exceptions. So these are the four scenarios that you have to be comfortable with in dealing with exceptions. Exceptions is a deep topic and it's one of the important things in Java. See, there are 2 or 3 things in Java which are very crucial. One is exceptions, second is threads, which we'll cover next. Third, which was recently introduced, is streams programming. Fourth is generics, which is also there soon. You know these 4 besides class. See, finally everybody knows what is a class, what is inheritance, what is overriding, what is overloading, what is base derived class, what is polymorphism. That any idiot finally figures out. Where the trouble starts is with these 4 ideas: exception handling, thread management, generic management, and streams. Streams is a recently added. And the 5th area is lambda programming, functional programming. This is also new. We have covered it in the syllabus, new syllabus. So we have to do it. So we are done with catch block, try block, and propagation. So here is just to check whether how much of exception. Be honest. Doesn't matter if you don't answer even single one. I am expecting that. There is a small MCQ quiz on exception management. So we'll just enable it. So just take it, see for yourself. You don't have to show us. You will understand on your own. So there is day 13, 7 June MCQ. So just click on it. We have enabled it and attempt it. We'll pause for you to answer. And then we'll proceed. We'll discuss the solutions and then we'll proceed. We have enabled the MCQ. Give it a shot. Try to do on your own. And please answer without doing on the... Don't try it out and do. You should answer without running the code. Okay. I think it's almost closing. People who have started little late will get a little more. Okay. So I think I'll wait till this reaches 200 and stop. Okay. So we stopped it. Now we'll go one by one. Try and understand what was asked. Okay. So let's go one at a time. So there can be more than one answers, as by now you must have figured out. There's not just one answer. So which of the following statements are true? Runtime exceptions are the same thing as checked exceptions? No. Runtime exceptions come under the category of unchecked exceptions. So A is wrong. B is runtime exceptions are the same thing as unchecked exceptions. This is another name for runtime exception is unchecked exceptions. All exceptions which are derived from or indirectly or directly from runtime exception class is called runtime exceptions or unchecked exceptions. You can only declare means report. Okay. You can only declare checked exceptions. No, not true. You can report, it is mandatory to report checked exception or catch it, but you can report a runtime exception also, not mandatory. Remember our code compiled, even though we had an arithmetic exception which was propagating, we did not say throws. It is not mandatory to report a unchecked exception, but it is mandatory to report or catch a checked exception. Okay? So you can declare only checked exceptions, wrong. You can declare only unchecked exceptions, wrong. You can handle only exception subclasses. That's true, no? Or throwable is also there. So, okay, any class which is derived from throwable is catchable. Throwable is all subclasses of throwable, not exception. Okay, let me just elaborate there. Can we go to the hierarchy? See, everything which is derived from throwable can be caught in a program. Throwable and that which can be caught. So subclasses of exception are there plus throwable are also there. This is a small thing you have to remember. Okay. Now, where are the answers? Okay, here is the answer. So runtime exceptions, runtime exceptions are the same thing as unchecked exception. All the others are wrong. You can handle only exception subclasses is wrong. You can also handle throwables, which are a base class of exceptions. This is something you have to remember. That's all. So the answer is that B. Okay. Okay. Now let's look at this question. When are you required to use a finally block in a regular try statement? When are you required to use a finally block? Never. When the program code doesn't terminate on its own, when where there are no catch blocks in a try statement. Yeah. So if there is no catch block in a try statement, then you need to have finally, because try will work either with catch finally or try with finally. If you have a try block, you mandatorily need to have a catch block also, either have a catch block and a finally block, or just have a try block, or just have a finally block with try block. Okay. So try finally will work, try catch will work, try catch finally is the recommended one. So if you have a try block and when there are no catch blocks, you will need a finally block. When there is exactly one catch block in a try statement, you don't need finally. When there are two or more catch blocks in a try statement, you don't need finally. So what is the answer? The block does not terminate on its own, I don't think is the answer. The C looks like the answer. When there are no catch blocks in a try statement, it is mandatory to have finally. It's asking when is finally mandatory. Okay? When there is no catch block and you have a try block. Okay? Next. Now this is a thing which may not have covered. Which are the following exceptions are thrown by the JVM and which are thrown by the, it's a good point. See, some of these things we get missed when we are talking. I have not discussed this, but this is a good time to discuss this. See, some exceptions come as part of the OS. They are triggered from the OS. So they are the exceptions which are triggering from JVM itself. Because the OS runs, the JVM, Java Virtual Machine, runs on the OS. So directly connected with OS, what are the exceptions? For example, array index out of bounds is an exception which comes from the OS because of the memory. Memory is managed by the operating system. So it's a memory related error. So it will come from the OS. So it will be a JVM exception. Then if you see exception in initializer, that is the exception which comes if the JVM itself is refusing to start. Again, it's a OS level exception. So it's a JVM exception, not a higher level exception. So array index out of bounds probably is an answer. Exception in initializer is an answer. Null pointer exception, Java exception, IO exception is a higher level exception. It doesn't come from the operating system. It has got nothing to do with the operating system. Then null pointer exception, number format definitely not. I think null pointer exception may be coming from the operating system because it's a null pointer. So I will go with A, B and D. Okay. So A, B and D. The other two exceptions, I'll tell you when they come. One is IO exception, when you're dealing with files. That's not related to the operating system. Then number format exception is when you're trying to convert a string into an integer, like an ABC. ABC is in integer string form. You're trying to convert it into integer. It won't happen. 1, 2, 3, if it is in string form, can be converted into integer form. So if you're trying to convert an alphabetic string, let's say, into an integer, it won't work. But an integer string can be converted into an integer. So that is when you get a number format exception. Next. What will happen if you add the statement 5 by 0 to a working main method? Will it compile? First, A is correct. A is correct. B is correct. It will compile or it will not compile? It will compile because it's a runtime exception. Compilation, there won't be issue. It's a 5 by 0 will give you a runtime exception, no arithmetic exception. So it will not have problem in compilation. Only when you run it, you will get an error. So it will not compile. It will not compile is wrong. It will compile. It will not run is correct because it will throw an exception, okay, called arithmetic exception. So it will run and throw an arithmetic exception. So B and C. and it will run and throw an illegal argument exception, no, and none of the above, no. So either I think we should go with B and C. Okay, Achha, he is not, he is ignoring B. The B and C together is the correct answer. Instead of saying B will not run, he is saying it will run and throw an arithmetic exception. Maybe that is a better way to say it. It is up to interpretation. It will not run means it will run and throw an exception. This I think you have to be given the benefit of doubt to do it either way. Okay? Because I will also think it will not run. What is the meaning of running? Running successfully without exception. So that won't happen. It will run, but it will throw an exception. Okay? Subject to interpretation. Now this is okay. Now there is something wrong, no there? Did you catch what is wrong? What is there? Try return A by B. Catch runtime exception is coming first. Catch arithmetic exception is coming later. And there is a finally block. So what is the answer? Will this compile? Always first judge whether it will compile or not. Then will it run or not? Will it compile? No, yes. To give a compilation error because you are catching the generalized exception first. Remember, runtime exception is the base class of arithmetic exception. First you have to catch specialize, then you have to catch generalize. So in this case, if runtime exception is at the top, what will happen? That arithmetic exception will never come. So it will, Java compiler will say, what are you doing? You should first catch specialized, then if they are not caught, then catch generalized. Generalized means base classes. And then the derived classes should be above. Arithmetic exception is the derived class of runtime exception. So this code will not compile. That's the answer. Okay, the code does not compile. Now, what is the output of this program? Okay, let's go through it. So public class laptop is the class. So it has a method start, and in the start there is try, and try is saying starting up, and it is throwing. There is a this is how an exception object is created also. This is what the JVM actually does for you. When it sees division by 0, it actually throws an exception class. This, he is throwing an exception class. So this is how you can also throw an exception class. So system.out, so you will get try block. When we do these questions, you should always start with main. Don't go with the way I am doing just now. Start always with main and then work your way out. So we are in main. Now we are saying new laptop and we are calling the start method. So start method starts executing. What will be the output? First output we'll see is starting up. Once we see that output starting up, what will we see next? It is throwing an exception. Then that exception is getting caught right there. You can see there. The exception is getting caught. Whatever is thrown in that block is getting caught right there on line 6. The exception is caught. The exception is caught, then problem is printed. So what have we got so far? Starting up problem. Okay. Then do see that simple thing. We talked about this system.exit 0, and then there is a finally block. So this is a classic trap question. So what will be the output? Finally, will it be executed or not? No. This is the only special case where finally is skipped when you do exit. So finally will not be executed. So what will be the output here? Output will be starting up problem, B. Okay. Finally will not be executed. Invariably people will say finally code also, whatever is happening in finally. But when there is a system.exit, there is no finally. That's the only situation in which finally is skipped. So finally will not be executed. So we'll have just those two, starting up problem. So that is the answer. So that's the answer, starting up problem. Okay, next. Okay, here is another. Again, you should, whenever you analyze this kind of questions, start with main and then proceed. So we are creating a dog, Leroy, called dog. Then we are setting Leroy.name is equal to Leroy, and then calling a method called parse name, and it goes on. Okay. So let's see what happens. Now dog has a public method, public variable called name, so that should not be a problem to access it in main. Anyway, it's in the same class, so it's fine. Then look at parse name, what happens. So parse name will first print 1, then it will enter the try block, it will print 2, then it will try to convert, this is important, it will try to convert name is what? Leroy, into an integer. See that, line 7, it is trying to convert the name into an integer. Obviously an exception will come. This exception is called, I just mentioned, number format exception. So the line 8 will not be executed. So the output I see so far is 1, 2. Line 8 will not be executed. It will go to the catch block, and the line 10 will be executed because it's a number format exception, and well, that's it. So the output should be 1, 2 and 4. 3 will not be executed because at that point there is an exception, and the next line after the exception, because there is a pending exception, yeah, we have caught the exception. Oh, I forgot about that. 1, 2, 4 will come from here, and if you look at line 16, because the exception is caught, line 17 will execute. I forgot. Line 17 will also run because the exception is handled. Remember, when the exception is handled, the next line executes. Because if parse name had not handled that number format exception, then 5 would not have executed. Here the exception is handled, 4 is printed. Now when line 16 comes out from parse name, there is no pending exception. So line 17 will run, and line 17 will say 5. So the answer is not 1, 2, 4. It is 1, 2, 4, 5. All these. Not 3. Except 3, everything is 1, 2, 4, 5. Yes. Good, good. Okay. Which of the following are unchecked, that is runtime exceptions? Okay. So array index out of bounds, is it a runtime or a checked exception? It's a runtime exception. We don't have to catch it, even then the code compiles. So it's a runtime exception. Illegal argument exception, we have not seen it. I have also not seen it. Okay, let's park it for a moment. IO exception is not a runtime exception, it's a checked exception. Okay. Now illegal argument will be a runtime, because unless you see the argument, you will not say it is illegal argument. So 2 runtimes so far. One IO exception is a checked exception, so we will skip it. Number format exception we just saw is a runtime exception. It comes at runtime. It doesn't have to be, you don't have to say catch or throws for it. Then any exception that extends runtime exception is a unchecked exception. So we have 4 so far. Any exception that extends exception? No. So we have array index out of bounds, illegal argument, number format exception, any exception that extends runtime exception. These are all called unchecked or runtime exceptions. Okay. So these are all runtime exceptions. Okay. Now we go to the next question. Okay. Which of the following are true? Checked exceptions are allowed to be handled or declared. Now allowed and required, there are this play on the words. It's not allowed, they are required. Checked exceptions either have to be handled, that is try catch block, or they have to be declared. Declared means reported. Declared is a word these people use for reporting an exception. So checked exceptions are allowed to be handled or declared? No. Checked exceptions are required to be handled or declared. I hope you know the difference between allowed and required. Required means compulsory. Either they have to be handled using try-catch block, or they have to be declared, reported. So B is so far correct. Errors are allowed to be handled or declared. Errors is the base class. No, errors won't come in that category. I think we can skip errors. Then runtime exceptions are allowed to be handled or declared. They are not required. So I will go with B and E. Now errors we are not are allowed. No, I think B and E is okay. Okay. Errors, the class of errors is they are part of throwable. I'll again show you errors. So they can be allowed. Wait. Go to errors. No, let's see the hierarchy, because these things come only in these kind of questions. So we'll look at errors and see the hierarchy in Java. So if they are derived from throwable, they are derived from throwable. Okay. So they can be caught. Anything which is throwable can be, not mandatory. I think mandatory. Throwable is mandatory because they are not part of runtime. So, okay, they are not part of the runtime exception class. They are part of the throwable class. They are not runtime. So, they come under the check category. Because they come under the, this is important. Okay. Many people miss it. Even I miss it often. So, error is derived from throwable, you can see. All throwables, if they were under runtime, then it is okay. You catch them or declare them, but they are not part of it. So they are required. If there is an error possibility, they are required to be caught and thrown. Caught or thrown. Okay. So we'll go with B, C, B, D, and E. Because runtime exceptions are allowed. They can be caught or declared, but it's not compulsory. Okay. Yeah. Oh my God. Which of the following are checked exceptions are allowed? No. Required. No, A is not correct. A and B both can't be correct, Baba. Okay, here there is an error. You can't have A and B both. Either you are allowed or you are required. So, I think B, C, E, that is correct. Okay. No, A is not correct. Checked exceptions are allowed, cannot be, no? Are required, either to be handled or declared. Okay, A is wrong. Okay. Now, which of the following can be inserted in the blank? Wait a minute. No. Which of the following can be inserted in the blank to make the code compile? So, system.out.println, work real hard, catch E, is not declared the type of E. Acha, where is the blank? The blank is for E. Before E there is a blank. Okay. So what are allowed? So the specialized have to come before. So illegal argument exception is allowed. Exception will not be allowed because it's a base class of runtime exception. You can't have base before. You can have derived before, base later. Base always should come afterwards. So now exception is not allowed. IO exception is not allowed. Illegal argument is allowed because it's a runtime exception. Runtime exception already is there, so it won't be allowed twice. Stack overflow is a runtime exception, so it may be allowed. So the answer could be either C or E, C and E. Stack overflow is a runtime exception. Okay, so answer is C and E. Okay, we come down. Okay, last I think. No? Which are the following pairs, fill in the blanks, to make this code compile? Acha, he is looking at, you are throwing a checked exception and you have to say throws. So oh no has to go with throws. And how do you create an exception on line 8? Throw new. I think we have not done this in detail. So line 7 B, throws, should have the word throws, that is a declaration of the method, and line 8 should have throw new exception. So throw new exception, yeah. So that is the answer, that's it. Now I agree some of them would be a little tough to handle at this stage because we have not covered, but shall I tell you something? Some of these things get covered through these questions only. I mean, it's not possible to cover everything in class. So these tricky things, sometimes you do them better when you are looking at a quiz and those situations come. Okay. So I think I'll stop here. So in the next session we are left with one more topic, which is called user defined exception. But my suggestion to you will be, go to Oracle book, that OCA, remember you have that book. Oracle Certified Associate, we discussed this in the beginning. Read that book, exception handling, only that chapter. Whatever we have discussed so far, you should be able to follow. Okay? Whatever we have done so far, using that you can follow that. Read it, come for the next session. Okay? So we'll stop here.